the second law of thermodynamics as applied to stellar metamorphosis, and as well as another bit of assumptions and their corrections. Now, the second law of thermodynamics is stated on Wikipedia. It's really confusing. All you need to know for realistic purposes is that you have a hotter object always transferring heat to the colder object. It doesn't go from the colder to the hotter. It always goes from the hotter to the colder. With establishment physics, they keep the fusion model regardless of if it's been falsified back in the 70s. They have a nuclear burning core, and then they have heat coming off the surface, and therefore it's really, really hot in the interior, and it's only mildly hot on the surface. This is a non-homogeneous star. It means it has two different locations for heat production, and as well, they assume that it's very, very old as the Earth, regardless of if the Earth is vastly older than the Sun, but that's more for later. Outer space acts as the heat reservoir or the heat sink, meaning it can absorb an incredible amount of heat, and it constantly absorbs it. Meaning the sun can radiate and radiate and radiate and radiate, and this outer space will suck up all that heat like nothing. Outer space doesn't care about how hot the sun is. Alright, in stellar metamorphosis, a star-like sun is a little bit colder on the interior as opposed to the surface structure, and the heat production happens on the surface. It's homogeneous, meaning there's no differentiation like the falsified model that establishment keeps. The heat has one location for generation, basically on the surface. Well, of course you have the coronal heating, but that's a secondary mechanism. And it's very young. It hasn't had enough time to form a core yet. So, and as it evolves, it cools and shrinks, and a lot of the heat that doesn't escape to the surface, that becomes trapped from the material trapping the heat, such as gas formation. I know hydrogen gas, when it isn't plasmatic, can block the heat from flowing. It has a very high specific heat capacity. Think about it like this: if you were to cover this star with water, the water would absorb all the heat, and then the heat would want to force itself inwards. So what happens is a lot of the material begins combining into molecules that can trap a lot of the heat. So the heat has nowhere to go to the outside, so instead of going outside, the star stops radiating and a lot of the heat starts moving inwards, and it begins heating up the interior of the star. This means basically that the star will remove heat in the most efficient manner, meaning the majority of the heat will escape, but it also becomes internalized. As well, the material becomes viscous, meaning thicker, like honey. So you have establishment models where they have hot, hot, hot coming out to the center of the star, hot, hot coming out the surface, and there's no real process for it to differentiate itself. They don't offer anything to differentiate the star because, according to their falsified model, it's already differentiated. But we know better. The star differentiates itself as it cools and dies. So you would have maybe like a sun-like star, very young, right here. And this would be maybe an early red dwarf stage right here. This also ties into the ability of the star to eject solar flares. And once it stops ejecting a lot of solar flares and the heat becomes trapped, it becomes what's called a brown dwarf, which is a tad bit smaller than the red dwarf, and will continuously radiate in the infrared from heating up the outer layers of the star. And it will be able to be seen with infrared telescopes. like the WISE telescope. You should be able to find billions of these things floating around outer space. So basically, to overview this, hotter to the colder. With this model, everything goes from the hot interior to the surface back into outer space, and outer space acts as the heat sink. But what actually happens is that the star radiates on the surface, radiating, and then around red dwarf stages where a lot of this material becomes, it traps the heat, it stops radiating, and then it will continuously wanting to go from the hotter to the colder. And guess where the colder is? The colder is on the interior of the star. So a lot of the heat will begin moving inwards. That also means that the rate that the star cools down and evolves will diminish considerably, meaning red dwarfs are vastly older in their stages, and brown dwarfs are even older than red dwarfs. And they have longer periods of evolution, meaning all those chemicals that are combining to, or no, all those elements that are combining to make, molecules and compounds and things are happening on the interior of brown dwarfs, and they begin happening in red dwarfs as well. Some very high energy molecular synthesis, reactions are happening in the surface of young stars like the sun. But that basically sums it up. It's best to look at, they have the correct assumption that the outer space acts as the heat sink, but all of their equations for stellar structure only focus on the internal regions right here. This is where a lot of the internal solar structure equations, and this is where they put all their energy, is this hypothetical, theoretical area that just basically is, well, I hate to say it, it's pseudoscience, because we now know what happens to the star. It forms the core as it evolves, meaning when it's young, it doesn't have a core yet. It hasn't had enough time to differentiate itself. Today is July 28th, 2015. If anybody has any questions or comments, please feel free to leave them below.